Okay, I am making this video because I am pissed about the AI slop getting into peer-reviewed research. And this one is at Bayesian and DeHide, published in HIPHIL Novum. It was research done on the Pauline letters attempting to use a bi-LSTM neural network to identify which letters are authentic and inauthentic. Now, right off the bat, anybody who knows anything about neural networks or AI can immediately identify the problem of doing a neural network applied to the Pauline letters, which is there's not enough data. You could figure that out right off the bat. And the fact that this paper went through without any sort of corpus expansion immediately should draw a bunch of red flags. So when I saw this paper come up, when I read it, it was ridiculous, and I knew that I had to write a response. But unfortunately, in discussion with the authors and the journal, I came to realize that HIPHIL Novum just publishes AI slop junk without checking it, and they do not have the competence to accurately check the papers they publish. So just to go over quickly what this paper was, it's called Authorship Verification of the Disputed Pauline Letters Through Deep Learning by Evie Bayesian and Dr. DeHide. Now, I talked to Dr. DeHide because when I read this paper, I immediately thought, this seems pretty suspicious to use a bi-LSTM using only 100-word chunks, far too small, for capturing enough signal to do real analysis on only about 450 chunks on the Pauline letters. It's just not enough data. You need as much data as possible in an artificial intelligence study in order for the output to be generalizable and accurate. And of course, we are limited on data when it comes to the New Testament texts. So I reached out, and actually in the paper, I found out that they have a GitHub repository, and it is obvious AI slop. What do you know? The study, which doesn't make a lot of sense off the bat, is AI slop. So I reached out to Dr. DeHide, and as you'll see, she was not apt to own up to the problem. But the study purports to train a bi-LSTM on chunks from Pauline letters. It also uses non-Pauline letters as a distractor corpus, as all studies do. And they found it was 84% accurate in identifying Pauline chunks correctly. Now, this doesn't make any sense, as we'll go on to talk about. Right when you go to their file, github.com, Evie Bayesian, disputed Pauline letters, and their preprocessing.py, anybody who has used artificial intelligence applications, LLMs to write code, can immediately tell this is AI generated. And I wrote a response, run this through AI code identifiers. It flags it as 100% AI written with 100% confidence. Once you see these doc strings, you immediately know it is AI generated. When you see it on every function over extremely self-explanatory code. Remove accentuation, the comment above, remove accentuation. Remove punctuation over remove punctuation. Convert to lowercase over dot lower. And when you're reading this, how are those comments helping anybody except if you were an LLM and you couldn't tell that people obviously know what that means, what a remove accentuation function is doing, or dot lower method. And the spacing is so clearly written by AI. So this is AI slop. On their GitHub repo, they say this isn't even the actual code they used. So they have published a study, which is completely non-reproducible, which on the outset, if you're not going to publish the source code, don't publish AI slop and pretend that it represents the source code. We have no idea if it is representative or not. How this passed peer review at HIPHIL Novum is incredible. They didn't even look at the code that was shared to identify, well, this isn't the right code. This doesn't make any sense. This is AI slop generated code. So I reached out to the author, Dr. DeHide. I said, this is AI slop. This is a fraudulent paper. And she said, in response, I can assure you that writing the paper and the code was an incremental process that took about half a year. Took half a year. Hashtag remove accentuation. Yeah, I don't think so. And I'm not confident that their actual code works in any way because we can't see it. We took great care in every choice we made in demodeling. We also had meetings with deep learning experts to discuss our approach. You didn't for this. You certainly didn't for this. Okay. And the fact that you put this out, you put your name on this junk, this AI slop junk, is shameful. And worse, that HIPHIL Novum peer-reviewed and published it. Nobody checked. Or maybe they did and they just had no clue what they were reading. Embarrassing. So I reached out to the journal and I said, this is AI slop fraud. They said, thanks for your message. We take charges of fraud seriously. We will investigate and return to you the decision. Okay, so I elaborated why this is a problem. It's not even necessarily that the code is AI written, but the author's denying that it's AI written. The code is, who knows if it's a representative or not. It's AI slop. It's ridiculously simple and it's wrong. The most important part is it's wrong and the authors aren't admitting it. So I agree the code looks AI generated, but we do not prohibit our authors from using AI tools in creating code. Nowhere is it mentioned that AI was used, by the way. Nowhere is it mentioned. The examples you mentioned highlight potential pitfalls when using statistical tools, whether written by a human being or generated with AI. Actually, no. A human being would not write this junk. A human being that's knowledgeable on the subject would not write this junk. That's the problem, is actually that it is AI. The AI part is pretty relevant to the whole discussion. We cannot prove the code is deliberately misleading. What does that mean? That they're trying to deceive you by publishing code that they know can't run? The code doesn't run as is. The code is AI generate. How is that not misleading? How is that not misleading? And it's obviously intentional, and you can prove to an extremely high probability that it is AI generated. The decisions made by the authors may still be problematic. We welcome a formal response. Okay, so I did write a response. Just to go over quickly the critiques, this is not all encompassing. They're using 100-word chunks for the BiLSTM, okay? So page 24, that's the format of these citations. If no other name is mentioned, it's coming from Bayesian to Hyde's paper. They present no justification that 100-word chunks is sufficient content for the BiLSTM to learn meaningful signal from, okay? And that is obviously not enough. And I say that because, again, if you're working with data, trying to actually make a useful downstream product, you're not going to rely on 440 100-word chunks. So each chunk is providing limited context for the BiLSTM, and the number of chunks is insufficient for learning embeddings that are useful. So their embedding dimensions is 61 to 70, depending on the technique that they're using. Okay, the model needs to see enough examples in order to push the embedding dimension, to push the vector in the right direction of the embedding space. Okay, there's not enough information with that dimensional representation to have an accurate model, to have an accurate study. Okay, and this is visible in the results. They say that the predicted probabilities for intra-epistle chunks range, quote, from nearly 0 to nearly 1, end quote, meaning it's completely useless. It ranges from 0 to 1. It ranges from the polar opposite to the polar opposite because it has not learned meaningful information. Okay, we should not observe polar variance from intra-epistle chunks. They also then took their model and attempted to classify 1 Peter, and they admit it did terribly. Okay, so then how is this effective, right? How is it effective? So 100-word chunks don't have enough signal, and there's not enough chunks in order for the model to learn. It's over-parameterized. Now, this, we could get into some technical details. Anything above 1-to-1 is obviously over-parameterized. Now, over-parameterized models can generalize well, but theirs doesn't. And with such a small amount of data, being so over-parameterized, it's obvious that this is going to memorize information rather than learn real signals that can generalize. So they admit this. Again, they say they know, quote, both model variants show signs of overfitting in the disparity between accuracy scores on the training and test sets. They also use dropout value of about 0.1 on their plain text model, which is far too low in order to overcome the overparameterization. So that's that. Circular logic. This is probably the most controversial point I'm going to raise. They assume that the 7 undisputed letters are actually authentic. But here's the problem when you do that. You're saying based on non-stylometric considerations, based on non-mathematical considerations, non-AI considerations, we're able to accurately judge what's authentic and not. Well, then what's the point of doing the AI study? If you already bias the model, whatever you tell the model is authentic, it's going to learn and consider that authentic, right? So you're just using circular logic. You've already told us what's authentic and inauthentic. And now you're just defining that as the authentic group, identifying similarities that can represent the authentic group. And then anything that's different is going to be different. Okay, so if you already accept that we can accurately identify authentic and inauthentic texts without using stylometric analyses or AI, then there's no reason to do the study. But if you think that stylometry and computational analyses can actually offer unique information, then you can't bias the study ahead of time. All of the letters should be unlabeled, and you should just see what data emerges from text to text. So that the model is not principally identifying an epistle to epistle authoritative signal and just rather reflecting the input assumptions, aka what they consider ahead of time a priori to be authentic, becomes evident if you just change what the authentic corpus is. So just by adding Titus, or rather just by adding 1st and 2nd Timothy and then judging Titus, the mean authentic value of Titus becomes 73.6 plus or minus 15% versus their 38 and 50% lemmatized findings. So just whatever you define as authentic is going to completely alter the outputs. That's not identifying epistle to epistle signals. That's just having the output reflect your input assumptions. Let's see here. Finally, I'm just going to touch on this. Again, there's many more points, but they use K-fold instead of group K-fold. And so there could be data leakage. All right. That's very simple scikit-learn stuff. Crazy enough, the peer reviewer says that even as an expert in the field, he didn't consider to use group K-fold. I submitted my paper. It took about a month for the peer reviewer to read it. And his response was just pure nonsense. I'm only going to highlight one section of it just because I could go on and on and on about this peer reviewer and how ridiculous his commentary is. But just to make one note, the author has a tendency to make assertions with no backing. With only 440 training chunks, there's not information to learn a useful 61 to 70 dimensional representation. I suspect his statement is somewhat accurate. Yeah, it's obviously accurate. He cites no studies about embedding dimension versus training day size. Again, if you're actually in the field, can you imagine thinking that I'm going to make an AI generalizable program using 100 word chunks? I'm going to do analyses on 100 word chunks with 440 samples. It's just such a ridiculous thing to say that anybody actually in industry would not take that seriously immediately. He makes several exaggerated claims through binary language. Results and methods are matters of percentages, not absolutely useful or useless. Thank you for that. If Bayesian and DeHaad's model is able to identify Pauling writing with greater than 80% accuracy, how does one claim the embedding space wasn't useful? Okay, and then he acknowledges the poor performance and incorrectly classifying also demonstrates the model did not learn meaningful information. But he says these are assertions without particular backing because it can recognize Pauling literature with greater than 80% accuracy. You just said it can't do anything when you're trying to generalize it to 1 Peter. You just acknowledged in your brain it stinks generalizing, but it's overfit to the data. So since it's overfit to the data, it's useful. No, dummy. That means it's overfit. And if you actually read Bayesian and DeHaad's paper, they admit it. The peer reviewer has no clue what's going on, unfortunately. So obviously the authors do acknowledge that the data is just overfit. They say on page 34, quote, both model variants show signs of overfitting and the disparity between accuracy scores on the training and test sets, despite attempts to mitigate this problem through dropout regularization. This highlights the model variants' limitations and their applicability beyond the training data. So the peer reviewer, well, what do you mean? What do you mean? It's not useful. It was able to identify it with 80% accuracy. So the embedding space isn't useful. They literally just said that. That it is not useful beyond the training data. So peer reviewer, you're going to defend a position that's not even in question because you didn't read their paper or you didn't understand it. The model's difficulty in correctly classifying chunks from first Peter combined with a wide range of probabilities observed for each tested letter calls for caution in interpreting its predictions regarding the speed of polling letters. This is scholar speak for our model isn't useful. It doesn't work well. Okay, peer reviewer? HIPHIL Novum is a joke. AI slop passes peer review. I wait a month for a guy to not even read the original paper and just get confused what he's talking about. What are the lessons learned here? All right. Lessons learned. 1, Bayesian DeHaad's work is erroneous. Do not just jump into the water and throw AI on as a fun little keyword to try and get clicks on studies. It's a fundamentally flawed thing to have a too small training set and a super small training set and demonstrate it doesn't generalize. Oh, look what we learned. What everybody knows, that you don't have enough data, which leads to poor outcomes. What everybody already knew, we're just going to do it again. We're just going to do it again and say, well, there should be caution interpreting results. You shouldn't be publishing that study. And you shouldn't be publishing it with AI slop code. How about that? HIPHIL Novum. This journal stinks. Publishes AI slop without checking. No more AI slop. How about that? No more AI slop in papers. Just write your own code. And if you're going to use AI, be honest about it. And if you're going to use AI, not only just be honest about it, but actually check to make sure what you put in there makes sense. Finally, HIPHIL Novum's peer reviewers, terrible. AI slop is now everywhere. And hopefully this shows that what HIPHIL Novum puts out should be treated with an extreme grain of salt. I would say just untrustworthy. And this brings up something I read on Schneier on security. I'm just doing this live. I want to show you guys this latest newsletter he put out. Let's do a keyword first here. I think that this is very good. Now, he's quoting somebody here, so I don't think this is Schneier talking. But he says, the theory is simple. First, AI gets accessible enough that anyone can use it. We're definitely at that point. But Bayesian and DeHaad use it. AI gets good enough you can't reliably tell what's fake. They're publishing this in 2025, and that code is obviously AI generated. So in this instance, that's not applicable. Third, and this is the crisis point, regular people realize there's nothing online they can trust. At that moment, the internet stops being useful for anything except entertainment. And what a great summary of the problem of AI slopping your way into biblical research. Because people might read this and think, well, there's now justification from the objective AI that some of Paul's letters aren't real. It's a BS study published by a journal who does not do their due diligence with peer reviewers who do not know what they're doing, and they don't even check the code, okay? And we need to stop the AI slop so that there's information online that we can still trust, because this is a real problem. We're already in a culture where you can't trust anything on the news, and what's true and fake becomes completely dependent on your moral framework that you're interpreting everything through. You're a conservative to begin with. You're going to see the news and think, fake news liberals, oh, Trump. You're a liberal. You're going to see the Fox News, but you're going to say fake government. Now the government's putting out fake information. We've already destroyed institutional trust in our society. We need at least, as scholars, to have a modicum, just a tiny bit of dignity, self-respect, accountability, and trustworthiness when we're publishing peer-reviewed research. AI slop in research, especially something that's as important to people as religion, is just unacceptable. Terrible study, terrible journal.